So hello guys, today we are going to do a little question that is subarray sum equals k. Question number is 560 and it is a medium level question. Let's see what the question is saying. First we will start by reading the problem statement. So you are given an array of integer nums and an integer k. Return the total number of subarrays. Return the total number of subarrays whose sum equals to k. Return the total number of subarray whose sum equal to k. It is a easy, there's nothing to just confuse about. It is just a direct question that you are given an integer array and you have to tell all the subarrays whose sum equals to a given target value. Subarray, what is a subarray? A subarray is a contiguous non-empty sequence of elements within an array. Okay, contiguous non-empty sequence of elements within an array. Okay, so what they are saying is if you are given this array 1 to 3 and your target or k equals to 3. So what can be a subarrays? What can be a subarrays that have a target 3? This can be a subarray because 1 plus 2 equal to 3. This can be my subarray, and also this single 3 can also be my subarray. The single 3 can also be my subarray. Okay, the single 3 can also be my subarray. Okay, so if I try to so this can be my two subarrays. So what is my count going to be? What is my count going to be? My count is going to be this one and this one. 1 plus 1 equal to 2. I have to return the number of subarrays, total number of subarrays whose sum equals to k. Okay, seems nice, right? So if I go with the brute force solution, what can I do? Brute force solution. If I try the same test case and where my k is 3, I have to get the sum 3. Okay, so I can simply make all the subarrays. I can simply discover all the subarrays, and those subarrays that have the sum equal to 3 can be my answer. I can declare a sum variable that is initialized to 0, and I can declare a count variable that is initialized to 0. Okay, I can start my loop from here. And I can start traversing till this element. I can start traversing to all the elements. Suppose if I start from first element, I can just stay to 1. I can go to 1 to 2. I can go to 1 to 3. Okay, and if I start from 2, I can go till 2 and 2 3. If I start from 3, 3 can only be my subarray. Okay, and if I want to check among these which are summing up to a target 3, so is 1 summing up to target 3? No, I'll just simply cross it. 1 plus 2 is equal to 3. Is it summing up to target 3 is equal to 3? Yes. So my count increases, count becomes 1. 1, 2 and 3. 3 plus 2 plus 1 is equal to 6. Is it summing up to my target? No. I'll just cross it. I come to 2. Is it summing to my target? No. 3 plus 2. Is it summing to my target? 5. Is 5 equal to 3? No. I'll come to 3. Is 3 equal to 3? Yes. So I'll simply increase my sum. So my count becomes 2. And this is the count that I want to return. I hope the question is now clear. And the brute force solution is also now clear. But what is the time complexity of this solution? As I'm running two loops, because one for the starting element and one for traversing all of these. Okay, so my time complexity is gonna be one for the outer loop and one for the inner loop. So O of n square. Space complexity is gonna be O of 1, because I'm not using any extra space. So how can I optimize this? Because 10 raised to power 5 means you can go up till 10 raised to power 5 only. Okay. Other cases will give like 10 raised to power 3 only. Other cases will give TLE. So this is not my optimal approach. So now I should go to the optimal approach. So I'll start by explaining you the optimal approach. Okay. How can I reach to the optimal approach? Suppose These are my array elements A, B, C, D, E. Okay, and there is some target K that I want to achieve, and this K is a sum of array elements. Sum of array elements greater than 0 or possibly greater than 1. Greater than 1 can be 1 and greater than 1. Okay, so I have to achieve the sum. I have to achieve the sum. Suppose I consider that my C plus G gives a sum. C plus G gives a sum that is equal to K. That is equal to K. Okay, that is equal to K. So if I try to get the sum to D, if I want to know what is the total sum till D, if I start from summing from the first element, so my total sum becomes A plus B plus C plus D. A plus B plus C plus D. Okay, and this is something that my sum till the element D. Till the element D. This is my sum till the element D. Okay, what I have said is this C plus G is my sum. That is my K. I'll simply replace it. So A plus B is my array and this is my sum. Suppose I replace this A plus B as a subarray. As this is a subarray, I'll simply replace it by Z. So Z plus K equal to sum. Z plus K is equal to sum because as you can see, this plus this part is going to be equal to this. Okay. Suppose you are on a number line. Suppose this part and this part, this is the total one. Okay, so if this part is my K, this part is my K, and this part is my A, and this part is B, so I can say that A plus K equal to B. I can say that A plus K equal to B. Seems fine. Okay, seems fine. And B is my sum. What is my B? B is my sum till the current element. Till the current element. I don't know this position. I don't know about this position. Okay, I don't know about this position. This is unknown. This is unknown. I'm just assuming that there is a K. There is a K. I'm just assuming. Okay. So if this A plus K equals to B, A plus K equals to B, I can just substitute this value towards the right hand side. So my K becomes B minus A. K becomes, oh sorry. So I can just substitute this K to the right. Substitute this K to the right. Okay, K to the right. So I can get the value till here if I substitute this K to the right, because if I substitute this K to the right, that becomes A is equal to B minus K. That is very sensible, because if you are given the sum and you subtract this part and you subtract this part, suppose this part you are subtracting, so what are you left with? You are just left with this part. Because you were summing up from the start. And this is what you get till here. So instead of finding the sum of all the subarrays, what if I just find out that there exists any number, sum of all elements till that number, sum of all elements till the current index, minus the target value, and if this sum is existing in my array, if this point is existing in my array, that means the K must also be existing. Because this was a hypothetical point. And if I am able to prove that this point is existing in my array, so I can easily prove that K must also be existing. Right? So I am just thinking, like, I'm not trying to do the sum of all the elements. of that particular subarray, what I'm trying to do is I am simply subtracting the sum till current element. I'm subtracting simply my target from this target, that means k in this case. And if this value that I get is existing in my map. Basically, I'll store all the sums in my map that I have achieved right till now. If I take this example 1 2 3, if I iterate, one is existing, so I'll store it in my map. I'll increase its occurrence. I'll store 2 in my map. I'll increase its occurrence. If I'll store 3 in my map, I'll increase its occurrence. Okay, so sorry, 6 in my map, and I'll increase this occurrence. I'm just summing. I'm just storing my sums. Okay, so this sum till the current element minus the target element, if this value is existing in my array, that means that k should also be existing. K sub array sum would also be existing, because as we just saw on a number line, if this is some hypothetical point and after this point is my k sub array and before this point is my a sub array and the total sum becomes p, if this point is existing, because if I do b minus k, if I try to subtract this and this, okay, so if this array is existing, that means that this second array would also be existing. And this second array is nothing but the target value that we want to get, also be existing. So this second array is nothing but the target value we want to get. Okay, so if we just find the sum, difference, okay, if we find the difference like current sum minus the target value, if we find it in our map, that means there is some hypothetical element present that can make my sum equal to k. Okay, so I have to do nothing. I'll just traverse each of the element, and at each element I'll just check whether the current sum minus k, that is the target, sum minus target, if this value is existing, if this value is existing in my array, if this value is existing in my map, if this value is existing in my map, then that simply means that the hypothetical point we assumed on the number line was a true point. That point exists in the map, and if that point exists, that means there is an array that is summing up to the value of k, summing up to the value k. Okay, so I'll just traverse all the elements, and I'll just simply check whether this value is present in my map. If this value is present in my map, I'll simply increase my count. By the number of times this value is present. Suppose if this value is present, if this point is at multiple locations, so all of these would give me a k. Okay, so there can be multiple subarrays. That's why I am increasing the value of count by the number of times that particular value is existing, the particular difference is existing, that particular point is existing. Okay, so if I try to explain it to you with a dry run, I'll take this example. Okay, and what are my array elements? 1 2 and 3. What is my k? K is equal to 3. Here comes my map. My map will store the sum as well as the frequency of that particular sum, as well as the frequency of my particular sum. I come to the first element. What I'll do, I'll come to the first element. I'll come to the first element. Okay, this I have to follow. This I have to follow. Sum minus target should be existing. If it is existing, I'll increase my count. I'll increase my count to the number of times that value is present. The number of times that value is present. Okay. If I come to this value, I'll simply increase my sum and simply increase my sum first. So my sum was initially 0. Now my sum has become 1. My sum has become 1. I'll just simply check whether 1 minus 3, that is minus 2, is existing in my map. I'll check the map. Is minus 2 existing? No. Minus 2 is not existing. So what I'll do is I'll just store this sum. Because this sum can act as the hypothetical point that gives my k. So I have to store the sum, not the difference, because the difference is the hypothetical point for that particular index. Okay, if this is not found, so that value is not existing. Okay, so you have to store that particular sum to that index, because this index can be an hypothetical point for the element that is occurring in future, that will occur in future. Okay, so what is my sum frequency? My sum frequency is 1. I'll go to the second element. I'll increase my sum. So my sum would be 1 plus 2, that is 3. Okay, 3. I will simply be decreasing it by 3. What I get is 0. So is 0 existing in my map? No. 0 is not existing on my map. But this is a valid subarray. So we have to add a condition at the starting. That 0 occurs one time. So it will just find this index. It will just find this index. What it will do is it will increase the count by 1. So my count becomes 1 in this case. And till the current value, what is the sum? The sum is 3. So my 3 gets stored in the array. 3 gets stored in the map. I'll move to this index. What my sum becomes? 3 plus 3 equals to 6. I'll simply decrease it by 3 because 3 is my target. I'll check for 3. That is the difference, whether it is existing in my map. Yes, 3 is existing. And how many times does it occur? It occurs only one time. So I'll increase the count by 1. I'll just simply increase the count by 1. Okay, so my count becomes 2. This is what I'll return. Basically, I'm doing nothing. I'm just traversing the whole array. I'm finding out if there exists a hypothetical point that can give me the k value. Because if up to that particular point my sum is the difference, okay, so it can give me the k value very easily. Okay, so in this case my answer is gonna be 2. If I check the test case, yes, the answer is 2. I was right. Okay, if I try the second test case, that is 1 and 1 1 1 1 1 1, I'll make a map that will store the sum as well as its frequency. What I'll do is initially I'll store 0 with a frequency of 1, because the first element can also make up to the sum 0, can make up to the sum target. Okay, all the elements included can also make up to the sum target. I'll move to the first element. My sum becomes 1. I'll simply decrease it by 2. Minus 1, is minus 1 existing in my map? No. I'll simply store this sum with its frequency. I'll go to the second element. I'll increase my sum 2. So 2 minus 2 becomes 0. 2 minus 2 becomes 0. So this 2, I'll just simply check my map whether 0 is existing in my map. Yes, 0 is existing. So I'll increase my count. I will increase my count. Okay, I'll increase my count. My count becomes 1. I come to this index. My sum is 3. My sum is 3. I'll simply reduce the target value. I'll simply reduce the target value from it. What I get is 1. Is 1 existing in my map? Yes, 1 is existing. But before that, I have to store this frequency also. This previous sum also. Okay. Is 1 existing in my map? Yes, 1 is existing. What is its frequency? Its frequency is 1. So my count would be incremented by 1. So my count is 2. And the iteration ends. So I'll just simply return my count. I'll just simply return my count. So 2 is returned in this case. 2 is returned. If I try to write the code for this, so I'll first declare an unordered map that will store my sum with its frequencies. I'll store this current sum and I'll make a count variable that will store the number of subarrays. Okay, I'll store the frequency 0, like the sum 0 with a frequency of 1, because all the elements could also make up to the sum. Okay, so 0 would be given a frequency of 1. 0 would be given a frequency of 1. I'll just iterate through all the elements. I'll simply sum them and I'll try to see if there exists a hypothetical point that can give me the sum k. Okay, that can give me the sum k. So I'll reduce my sum with k, that's my difference, and if that difference is existing in my map, I can simply increase my count with the particular value, with the particular frequency of that difference. Okay, and what I'll do at last is I'll simply store my current. I'll simply increase my current sum by one. Okay, as it is occurring one time till that index. I'll simply return my count. I'll try to run it. Okay, and I'll try to submit. Okay, submit it. So if I try to summarize, what I'm doing is basically I'm not checking, instead of checking for all the subarrays that can give me a target, that is x plus k, is that particular index, that is particular array that can give me the sum till the current element. So this x acts as my hypothetical point, because till that index, if I find that sum previously, so I'll just increase my count with the frequency of that particular difference. Okay, so it would give me the count. If I try to tell you the time complexity of this, as I'm traversing only once, so my time complexity becomes O of n. And what about my space complexity? Space complexity, as I'm using an unordered map in this case, so my space complexity is O of 1, O of n. Okay. So this was the solution of the question subarray sum equals k. I have discussed about the brute force as well as the optimal approach. If you have any doubts, you can just ping them in the comment section. And if you like the solution, do like, share, and subscribe. Have a nice day. Bye bye.